Everyone, hello, I'm Chris Field. I'm the Secretary of the Railway Division South East, and welcome to this evening lecture hosted at the RSB very kindly for us. A little bit of housekeeping, very simple. The emergency exits are down the corridor to the left, follow the green signs. We're going to follow Barry if anything bad happens, but we're not expecting any fire alarms. So why are we here tonight? We've all got an interest in seeing engineering innovation and improvement on our railway. One of the barriers to implementing change can, of course, be the lack of suitable test facilities. Professor Andy Doherty is here tonight to tell us about the Global Centre for Rail Excellence, and his role is to provide vision and leadership to the technology and strategy and development for the UK's first full-scale railway innovation facility, designed to provide full testing of train infrastructure and system integration, as well as validation and certification. Andy is a fellow of the Royal Academy of Engineers, an electrical engineer with, of course, a huge amount of railway experience, having previously been Chief Technical Officer at Network Rail and held several senior roles in London Underground. So please join me in welcoming Professor Andy Doherty.
Good evening. Just as a quick poll, I gave the Curry lecture in March, and I did talk about this. Was anybody there? Did anybody hear that? Yeah. One or two people have heard, but majority haven't. So the good news is for you, I've fiddled it around a bit and changed things, and it is an evolving story. For the rest of you, it'll be new, so that's good. So you won't need pillows for that sort of thing. I'll try and keep you awake for this talk. So I'm going to talk about this thing called the GCRE. It was the working title, the Global Centre for Rail Excellence, but it seems to have become the title, if I can put it that way. In that we were doing some, inevitably somebody said, oh, we'll get some marketing people in and have a look at, a good name for you. And in the end, I think we're still sticking with the name because actually you spend a huge amount of money changing brands and things like that, don't you? And not everybody ever remembers that or knows. It's always a bit of a surprise. So I think it's better to stay where it is. So I'm going to give you a bit of an update in the process. I call it evolving story because it is genuinely an evolving story of where we are and where we're going, and things are happening as we speak around this with others. So I'm going to tell you a little story about that. So where are we? The first thing to talk about is this bit here. So Swansea, Cardiff, Newport, for those of you familiar with that. Brecon Beacon's up here, and this red blob here is the land. It was something called Nant Helen coal mine. It was an open cast coal mine. Prior to that, it was the Onfluen and various other places, deep mines. So it goes back 200 years. It's good quality anthracite coal. And the only reason it stopped mining, because they were sort of basically doing open cast mining, and they've been chunking across from the east to the west, and they run to the magic pencil line on the map that is the planning permission. And Welsh government policy is no new mines, no extension of planning. So they stopped digging at the point where the coal seam was 11 metres thick with anthracite in it. And it is anthracite, and we can't. Apparently, it's a good thing to import brown coal from Poland and various other places. That's beyond my pay grade to understand that, but it is a good thing. So there's about another 30 or 40 years of coal, apparently, at the rate they were extracting it, but we can't. So luckily for us in the railway sector, having spent 20 odd years saying we really need a test centre in the UK and not being able to find one, having looked in deepest Scotland, the Isle of Sheppey to Lincolnshire to you know, extending Tuxford and all sorts of places to try and find somewhere. Tried in France with the French to build something near Valenciennes in the part of Calais. And again, they couldn't get planning permission. Even the French couldn't get planning permission. Their wheeze was to build it right next to the Belgian border. So they didn't have to consult Belgium because it's a different country. So they could just, and even then they couldn't get planning permission. The difference here is that the Welsh government was saying, well, got to close these nasty coal mines, but that is actually the last 150 jobs in the area. It's not exactly, it's a fairly, well, I'll put it the other way, it's a socially deprived area. So when the last jobs were going, that's really bad news. They've been blasting, of course, for 40 odd years there. So when you said to the locals, well, your mine's closing, but we've got this wheeze of a railway test centre, and it's going to create some jobs for you. And they said, no blasting as well? Yeah, all right, good, jobs are good. And so actually we have planning permission to run this 24/7, which could knock me over. I didn't believe, I was amazed when we got that. So we have planning permission. It's 700 hectares. So it's basically the size of Gatwick Airport, Heathrow Airport, that sort of thing. Kind of a big site. It is connected to the main line by a branch line. This is in the sectional appendix as the NAB, the Neath and Brecon Railway. Went up to Brecon, which is over here somewhere. Closed many years ago, but it's been running as a coal traffic railway until I think the last coal traffic went out in August 22. But it's still open, it's still in the sectional appendix. So it runs into the Swansea boroughs. You have to reverse out and along and away. It's actually gauged for RA9/10 being a coal railway, and theoretically W6A. I don't think a W6A train's run on it for some time. But there are no structures on it. So we think we can even get a 26 metre up it, because you can get a 26 metre vehicle into the Swansea boroughs. So if there's nothing obstructing us to get it up, we can get something like that up there. So a quick overview, I'm going to take you through lots of little bits about this. So we're trying to build basically a world-class research, testing, certification facility for trains, infrastructure, railway technology in general. I think it will go a lot further than that, but that's certainly the task. We want to be able to do that so we can do it faster. We can get to certification of products quicker, get them implemented on the railway. And there's obviously lots of facilities aligned with that this thing has to do. We're trying to link that with the universities, and I'll tell you all about that. I'm trying to create space. I mean, there's kind of a lot of space, so we're trying to create a sort of technology park, a bit like Mira or Silverstone. You see the amount of buildings and facilities that are now sort of co-located. We're trying to move that onto the sites as well, so 24/7, and we're trying to sort of build it net zero, sort of sustainable, low carbon, and net zero in operation. Again, quite a story, that bit. So overview of the site. Basically, the railway comes up through the middle. This is the railway line there. Actually, we're building a whole load of sidings on top of where there were a whole load of sidings for the railway, so for the coal mine. So apart from lifting it up about 1.5 meters to deal with water issues, it's similar. Headquarters will be down here. There's huge space for sort of technology park, and the railway is going to be this large thing here. The mine had been digging across here. This hole was 250 feet deep at the point of stopping. It was a big hole. They put 7 million cubic meters of soil in it to fill it up. There's a large bit here that's got something like 50 million cubic meters of soil. It's kind of a big hill. This is the Brecon Beacons are up there. It is a hill here. I think if you're Swiss, you'd feel very comfortable about building a railway on here. It's certainly not flat, which is kind of an interesting bit. You can't see that from the topography. Essentially, the railway is about 200 feet higher than there. So it's quite steep up here, 1 in 50 to 1 in 37 on this sort of last bit up here. So getting trains up it will be entertaining. But that's what it's all about, fun. For those that gave here previously, we did originally plan to have the infrastructure loop as a sort of separate loop in the middle here. The problem was that it was going to be in cut. It was going to be something like 20 meters of cut all the way round. That was about, well, in the end, about 2 million cubic meters of soil. So we decided it was always going to be double traced for future expansion. We decided to put the vehicle loop and the infrastructure loop on the same trace, because that actually saved quite a lot of money. And we've actually done a little bit more work, so we're wasting this in now a bit here, because we did have a rather large embankment in this area here, and the nearest house to us is just there. And there was sort of 40-meter embankment to it, which was all right if you're looking from the top, but when you're looking from the bottom up, it wasn't so good. But we've now got it down to a 10-meter embankment, and it's a lot further away from them. So I feel better about that as well. So we've been value engineering the site to try and to maintain the functionality. And I think we've still got 95% plus of the functionality, but we've taken the best part of 100 million out of the cost. So rolling stock facilities will be the outer loop. It's 7 kilometres long. It's going to be able to run the trains at around 180 kph. Could run at 200 if we start going to cant efficiency a little bit. Not sure we need to do that, but we could do it. Say we will run it in sort of 3 8-hour shifts, I should say, and we can. And the difference is you can run continuously. You can run all day. You can do endurance testing. Kind of difficult to do at Melton, particularly with their planning restrictions on Melton. It's only 4 or 5 operations an hour between 6 and 8, isn't it? So the idea is to run continuously. The idea is to have the certification on site such that we can get through that process much faster, and it'll be supported by all the sort of facilities behind it. I'm going to show you some details about how that happens, because this is an institution discussion. We're allowed to get techie. I'm never allowed to do techie at sort of all sorts of public things. So, oh, we don't understand any of that. So we'll talk about that. The infrastructure loop is the inner loop. So we're going to talk, for those, I suppose you put it this way, the vehicle test loop is about testing the train, and the infrastructure is kept constant. And it's a simple matter of science. So the other one, the infrastructure loop, we keep the train constant and we fiddle with the infrastructure. And we just control the variables. It's just knowing your variables, knowing your constants is the secret to good science, isn't it? Again, the idea is to test the infrastructure and actually test it all the way through to its end of life. So it's a through life testing facility. So if you go to oil and gas, if you go to aerospace, Rolls-Royce talk about through life testing, and they literally do. They take a brand new Trent engine, latest version, put it on the test rig, run it up and run it to destruction. They don't want to destroy it, but they want to know where the failure occurs, how it fails. They need to manage that process. We need to do that in railways much more, given that CP7 is, what's it called? Managed decline. How many of us as railway engineers have listened to the bit about managed decline? It's a sort of sad world, isn't it? You know, the main line has 40,000 bridges on it. We replace 250 a year. You can do the maths as easy as I can. They're all getting older. That's managed decline, isn't it? But we have to be clever at knowing that, and we have to know the degradation curve. Most of our standards keep us in the nice constant bits at the stop, and we don't like when the curve goes off and starts going down. The standards tend to stop us from operating those areas for good reason. But actually, if you're going to manage decline, you need to know what's going on as you decline. That's what the graph tells you. So again, I'll tell you a little bit more about that. And obviously related to that, there's the whole question of certification. Certification, there's sort of a four-box model for me. There's clearly the company in the UK manufacturing a product for the UK needs certification, whether it's UK CA or BSI mark, and Network Rail stroke other integration marks on it as well. There's the UK product that's being sold abroad, that's being sold to the world, so that's export. And then of course there's many companies importing to the UK which need to be certified for the use in the UK. And of course there's a mythical one, which is the company making something abroad that's actually going to use a facility in the UK to certify it and then sell it to the abroad. It's possible, maybe not so big on the agenda, but it's theoretically possible. But the whole point is, if you take a product in the UK, you invent a new switch machine, God help you, it'll take you 5 years to develop it. It could take you a lot longer if you look at Repoint or things like that. I think, generally it takes you about 2 years to get a test certificate, and theoretically that's for 6 months operation, and then theoretically it should be removed. There's a lot of them that have not been removed, but the reality is the main line is not for testing people on. We shouldn't be testing our passengers on those things. So it is a controlled process, but it takes a long time. The idea of this is that if you don't have any people involved, you can move much faster because you don't have to evaluate so much of that. And the idea is to be open for SMEs to large clients, to the class 1 type supplier, but to be a showcase for those companies to sell their product as well. The logic is very much that it's 100% separated railway. So it is, I sometimes call it the Isle of Sodor. And Thomas the Tank Engine and the Fat Controller. Some of this is, I don't know whether it's legal to say that anymore, but but a controller, a separate controller. It's a separate railway, but it represents the real railway. It's not brand new. It's actually going to be a used railway. It's going to be averagely used railway. So it's more like the real railway rather than, because how many trains have we tested recently, and they all work really well on a test centre. You put it on the railway and let's say it doesn't work so well. And we've got a list of issues like that along the years, and Crossrail being the recent one, but there are many like it. It is going to be physically separated from Network Rail's branch line. So Network Rail's got a safety case for its branch lines, technically a public railway. We will be connected but physically separate, and we're going to separate the human from this as much as we possibly can. So we're going to keep people away from the testing by all sorts of means, so we can actually test in a more aggressive way. So it's a mini Network Rail, if you like, with a mini independent ETCS and GSMR system. All the loops are fully independent, the siding areas are fully independent, and I'll show you just how much of that I mean in a minute. We can remotely operate it, manually operate it, automatically operate it. As I'm sure many of you are involved in the design of new systems here, even the interlocking will be in the cloud soon. So does the interlocking have to be on this site? Could it be remotely controlled? Can you remotely control a train? Well, yes, you certainly can. There's certainly lots of things that we can see coming forward in that sort of area because of the population density in the area. We're largely spectrum free. Ofcom are relatively relaxed about us using all sorts of different frequencies on here, and certainly the new FRMCS frequencies, of which there might be a UK and a European one because they might be different. We can probably use both on this site and all the 5G stuff. And we're going to talk about digital twins, etc., etc. So that's the logic of the site. So the actual system itself, where to start? So the outer route I say we're keeping the infrastructure constant. So the infrastructure of the outer loop is technically a Class A future railway. So it's ETCS, full standalone, brand new ETCS Class A. That will be baseline 3.4, 3.6, 3.8, depending on where we are at the time. It'll have its own interlocking, its own RBC. It's 25 kV, and it's actually going to be European gauge. We're going to go European GB ABC gauged for that, and obviously UK running as well. But that's because we could then run and test European trains. So there's very much its own loop for the train to be certified against it. So that infrastructure is about being the future system, and you test your train against it. The inner loop sort of counter the opposite. So it's actually signaled with traditional signaling, so all the normal stuff that we expect, track circuits, axle counters, TPWS, AWS, with a sort of ETCS overlay. So it's a bit like East Coast. So it's a Class B with an overlay, again with its own separate interlocking and RBC and 25 kV. Most of the track for the inner loop will probably be recycled. With a lot of it will be reused, recycled material. That's good for sort of a sustainability issue, but actually puts us into the world of the real railway rather than a brand new railway. You know, the outer loop will have to be, if you like, certified for 200 kph, and so yes, it will probably be brand new rails and brand new sleepers. The inner loop, much more traditional, whatever a traditional main line looks like, sort of 20, 30 years old, etc. But it's used in that sense. So full fibre around the whole site, under bridges, over bridges, and some of those under bridges and over bridges might be carbon fibre. The sort of whole of the process here doesn't need to be certified in the loop. It's actually, there's a lot about, there's the chicken and egg here. So if you haven't got your product certified, how do you put it on the railway? Well, you can't, because you haven't got it certified. So you have to get it certified first. So the question is, how do you get it certified? Well, you can put it on here because it's tolerant to that situation. And that's the purpose of this. To say the sidings and the link road are separate, and the branch line is very, very separate from the main line, so we don't pollute their safety case, and they don't pollute ours, we hope. So that's sort of conceptually how it is. It's a through life facility, and that's about offering to put a load of infrastructure on it. So we have bought 3 Class 60 D0s. One careful owner, slightly used. And there are mules. The opportunity of that is they're not owned by Roscoe. We're not going to need to get permission from the Roscoe to drill a hole in it. They're basically mules for testing. They're not mainline certified. So they'll run that and a freight train, so a euphemistic electric freight train with 30-ton axle loads, because I need to accelerate the load. I need to put a lot of tonnage on here quick. And actually, if I go nasty on the loading, what I'm doing is pushing the tonnage, the equivalent tonnage, even higher, because I'm now outside the standards. I'm now doing something that's worse. So sort of 20 million tons equals probably 30 or 40 equivalent tonnage. We'll run it 16 hours a day, 5 days a week, and then we'll run for 10 weeks, and then you stop it. You have a downtime for a period where you can rip out stuff, put new stuff in, and carry on again for 10 weeks. Now, some stuff will be in there for years, frankly, and some stuff will be taken out as and when it needs to. The train on this loop will be automatic, so we're not going to have anybody in the train, because if something goes wrong, we don't want to hurt anybody. That's kind of important to this. So that's the concept. And again, because I couldn't quite have my way, and I'm still a little bit upset about losing my loop in the middle, because the great thing about the loop in the middle was it was in a cutting, and it really didn't matter. It could go anywhere because the cutting was going to constrain it, and everything was good. But I can't have that. So the equivalent is I've created, there's a section here where we put a bund in. We're going to put a bund between the main, the vehicle testing and the infrastructure testing, so that physically one can't get to the other. And it's that area that we will use for whole life testing. You can do lots of testing around here, but if you like, the standard that I'm working to, it's got to be more controlled, because can't have a migration between the two. Here, I can be a lot more aggressive on that, because I don't want to say I don't mind, because I sure hell do mind. If you derail the train, there's an awful lot of mess to clear up, and it does cost a lot of money. I might not have hurt anybody, but it's still a mess. And it still takes a lot of time to fix, doesn't it? So the idea is not to do that, but even so, you need to, have a separation. It's about protection of people and control of the science that we're doing. You have 2 tracks in here, because one track I need to have design defects in. So the idea is to put all the exceedances that are in the line standard, 3 meter twists, maybe even some underground 2 meter twists if we're getting really ridiculous. Other sort of defects in there that you can now certify a train on. You can run the train over and test all its sways, all its all the things that we like to do as rolling stock engineers. But I wouldn't want to run them on that continuously, because I'm going to knacker my trains on that as well. So I've got sort of one track that I've got all the nasty bits in, and the one that actually I'm doing experiments on. I might have composite over the line. I might have some different rail metallurgy, which I'm allowing cracks to grow in, to see how fast they propagate. Because after Hatfield explains to Network Rail that yes, we needed to understand all about rolling contact fatigue, and we wanted to do that by growing small cracks. The board weren't really very happy about that idea, so I had to go to Pueblo for that, which was sort of the genesis of why don't we have such a facility in the UK to do that. So that's sort of part of why we're trying to do this, is because you need to extrapolate, you need to take your equipment through to life and understand the management of failure. So that's sort of conceptually how it works. And I'll just use the case of HS1 here. HS1, no. So HS1 is now what, 15 to 20 years old, depending on which bit of the line you're on. They have an asset life planned of 40 years. 40 years. And they've got private investors, pension funds and all sorts of things own them. If actually that asset life turns out to be 35 years, they're financially ruined in the form of things. If it was 45 years, they've just missed a massive opportunity, and they'll be told they were stupid. The accountants will say, well, look how much money it cost us. The reality is, how do they know? Well, actually, it is like that. But if we took a section, let's say a string, 2 strings, 216 meters of pre-aged 20-year-old HS1, you put it in here, put it in the GCRE, run it with the heavy load on it continuously. In 5 years' time, that bit of railway is now, like the mainline railway, somewhere between 20 and 25 years. But the railway here is at 30 years. And actually, as you go forward, it gets into the point where it's starting to fail. And now HS1 gets the opportunity of saying, well, actually, if we changed our maintenance, we could extend that life. Or if we changed that component, because that's the first component to fail, we would avoid that failure. And it's usually a chain of failure that goes on then. If your clips start failing, or if you start breaking out the sleepers or things like that, there's things you can do before it happens, but it's usually too late, because by the time you found out, it's sort of, oh, I wish I'd known that 5 years ago, because it's kind of difficult to go backwards. So the idea is to, if you like, extrapolate forward so you can see, and gives evidential information. And accountants like that, don't they? They prefer us not to be good engineers and working on experience and custom and practice, etc. But to actually put the science behind that as well. One last thing about that is that if we run this facility as a figure of 8, running from the outer loop to the inner loop, we will be doing a transition not only from sort of the new railway to the old railway in a physical sense, but also in an electrical sense. So we're going through a transition of ETCS, we're going through a transition of the interlocking, a transition of the RBC. Potentially we could probably force it to do a GSMR type transition at the same time, which is a replication of Crossrail to this world and things like that. So we can really accelerate forward some of those things. They all work in the lab, but we all know that the situation is that some of these things don't work quite like that. You've always got the latency in the equipment, just when it happens that there's a dip in the radio frequency, or just when the train's doing a cycle of some other part of its system. Legitimate, but actually there's sort of things that you try desperately to catch in a laboratory, but do you? Evidence shows that we don't always get that right. So actually having a facility to do that is what we're trying to achieve here. So the operating philosophy of the place is that it's a giant laboratory, except it's outdoor. It's outdoor with 2.5 meters of rain, rather a lot of wind because it's on the front end of the high hills, and the next stop is the Atlantic, and it's really quite windy up there. It doesn't have to be limited to railways. It could be other systems as well. And fundamentally is you can test and develop non-approved products to the point of getting them approved. That's the point of it. And through the asset life to obsolescence. Understanding the failure mechanisms, etc. When we did the Central Line trains donkeys years ago, and we had Vapor doors. Vapor actually agreed to build a test rig in America, in Canada actually. The funniest thing going, sending Oliver Freed with 2 bags of tunnel dust through customs at Heathrow to Canada with him. And when they said, "What's in the bag?" "Tunnel dust, mate." And they said, "Well, we'd like to look in the bag." He said, "I really don't think you should open the bag." And they did open one bag, and there was a large puff, and they said, "Oh no, shut the bag." Because otherwise that tunnel dust would have been through Heathrow Airport as well. And they'd have been living with it. Anyway, that test rig was running, I don't know whether it's still running, but it was certainly running for 20 odd years.
Running a few years ago.
Yeah. Magic facility, really, because it really gives you an understanding of what's going to happen before it happens to you. So the idea of this is to be risk managed, risk tolerant, as opposed to risk averse, which is what we have to be on the main line. And so I've said a lot of this. So the idea is lots of fencing, 33 kilometres of fencing, I think is actually the count for the site. Lots of surveillance to exclude the public, because inevitably there's 2 public footpaths across there, isn't there? So we've got to make sure they stay on the paths. With a continuously monitoring that, complete separation, where we're doing that sort of testing, operating automatically, and really part of this process is to be agnostic to the thing, to allow the supplier to say, well, actually, I've got a new thing, it's completely different, it doesn't work the way that you normally traditionally do things. Well, you've got to be able to allow that. We were talking earlier about the SETI train was a D-stock with wheel motors independently operated. Really weird train. It didn't sound like a train, didn't flange at all because it's perfectly steered, never touched the flanges anywhere. Didn't sound like a train at all to me. But actually, sort of the ORR was saying you've got to have an axle. And I was saying, well, we don't really need an axle. So they had a sort of almost a cardboard cutout of an axle on it. I thought that was very amusing, actually, particularly as the ORR had swallowed it, which I understood either. But they had. So the operation very much is, if you've got a big crack, how do you know whether it's safe to run, even if you've got nobody on it? And the answer is, I've seen at Pueblo, you know, they had a crack in a bridge 2.5 meters long. And I thought, oh, really exciting. It was complete through the base plate, going up through the I-beam, and as it always stops, and then it starts again. It stops, and sort of bloody hell, that's a big crack. If on the main line, we don't, they have to be out. Whereas they would say, no, it's really interesting. We'd like to know. But clearly, you get to a point where it starts showing serious distress, hopefully before catastrophic failure. We did have a catastrophic failure of a bridge up in Scotland a couple of years ago. No, showing my age now, it's probably about 7 years ago. And when the bridge came out, it was actually 1 week before the bridge was due to be replaced. There was a brand new bridge sitting next to it, ready to go 1 week later, but it failed. When basically we looked at it, it was kind of a miracle. It was standing up because there wasn't any metal in it. It was all rust. It was completely rusted away. All our assumptions about, well, it's 10 millimeters thick of steel here, and it shouldn't, erosion rate would be this, and therefore there should still be 6 millimeters left or something. Well, nothing. Absolutely nothing. We hadn't accounted for the Scottish weather, I think, probably. But the reality is, it was quite surprising. It was still up, but inevitably it came down, caused a bit of a kerfuffle because it was a freight train, caught fire, all sorts of naughty things. But that was that managed decline? No, it wasn't. That was sort of catastrophic decline. So we're going to run this on a sort of regular basis of what does it look like? Is it showing distress? Is it getting a bit further? And doing that on a very, very regular basis. So it's continuous monitoring of that sort of process, and using a digital twin, which I'm going to go on to. So we've actually started down this road. We've been building everything to BIM 2, and trying to force all our suppliers to go to a standard nomenclature for the data, which has been quite an interesting journey, frankly, to get them there. We've done some 3D rendering of the site already. We're going to migrate that data into a digital twin if we knew what it was, because there is no standard for a twin. There's lots of initiatives from the government through to every big industry player is all talking about this, but actually all doing it differently to some extent. So how do we get there is a journey that we want to go through with our suppliers, with the industry. But the idea is it's a backbone to operate the site, to monitor the site, to allow hardware in the loop, to allow simulation, to allow remote operation. It just goes on and on, the list of it. But what we're quite clear is that it's essential to enable this thing to work. And through that, we open the door for the universities to remotely operate it, to apply an element of their science into this process at the same time. We do anticipate this is all about training and development as well. So we're already part of what is Ukraine 2, the thing that was announced, when was it, last May time, I think it probably was now. Another 90 million of research funding led by Birmingham University, but with the usual university train behind it, from Southampton and Huddersfield to Loughborough to, well, now Cardiff and Swansea and various others joining it. But the idea is to do high TRL development and implementation of the research from here. But it's also about apprentice training, apprentice levy processes with the local universities, local colleges, railway specialist supply training as well. Birmingham University has sort of been running various courses, and part of their sort of various training scheme, various degrees they've got, they've been using heritage railways because they can't get near the main line. In fact, they were going to, I think they were even struggling with the heritage railway, because I think they went to Portugal this year because it was easier to get on the Portuguese railway. Don't know why that's easier, because the risk is the same, isn't it? But notwithstanding, they were going there. Well, that's a bit crazy, isn't it? So wouldn't it be good if we were doing it in a sort of controlled environment here? We're also doing the primary engineer process. We've got 14 schools in the local area signed into our process, or the process, I should say, of which we're a party to. It's a journey that we've all got to go through. The whole STEM process, the whole training process is critical to us all. There's lots of initiatives all around for this, because we're sitting here as engineers talking about some of these things, but it's important that we carry on that process. How do we encourage more youngsters into the process. Not everybody is a natural engineer. There's a lot of need to train people into and open their eyes to this wonderful thing called engineering. At least I'm biased, but I didn't have a choice, so I just did it. A little bit update on the funding. We got 70 million of sort of public sector support, 50 million from the Welsh government, 20 million from the UK government. Kind of unusual, both governments actually giving us money. They don't usually talk to each other. One's Labour, one's Conservative. But we did get that. We've got 7.4 million of a sort of Innovate grant. We're just about to award the part 2 of those innovation grants. And those lucky companies are actually going to build their system into the railway. They will be part of the build. So some of those innovations are going to come in very quickly. And obviously the GCRE, Ukraine money is also coming onto the site. We started a public procurement in January. Not the best time to start trying to raise some money. Like buying a house at the moment, not a good idea. Interest rates a bit high. Inflation quite a bit too high as well. So kind of difficult. Money's not there, but there is money. It's a question of affordability of money. So what's the rate of interest? And so the investors are sort of saying, well, you've got to reduce the risk on us. If the risk is this high, then the cost of money is high. If you could lower the risk, then we can get the cost of the money down. So the discussion is still ongoing. It is actually coming to a conclusion. I'm sorry, but I'm not allowed to tell you, but we're all very confident we're going to get the money, the rest of the money, another 250 odd million we need to build this thing, if we're building everything. And actually we're pretty confident, and there might even be some good puffs of white smoke in a few weeks' time, in a very small few weeks, actually, if it all goes well. It can always crash and burn, can't it? But we're kind of hopeful it's going to happen. I think we'll knock everybody dead if we can do that, because it's going to be pretty stunning. We're planning to start, we are literally ready to start in the spring. We've recently had to cancel most of the site visits we've been doing because the weather's been too bad up there, and we never planned to dig over the winter. It's just, you just can't. It'll sort of, where's my digger? Or lost it in a big hole. It really is pretty poor up there. So the plan is to start digging next spring, start putting the railway on in sometime in 25. It's sort of an iterative process, because we've got to get all the construction done during the summer months, because the weather is just too bad for construction. It'll be fine for operating, because quite frankly, running the train round here will be like putting a train across the Pennines or across Sham Fell and things like that. Because if it don't work on here, it ain't going to work on any bit. It really is quite a proper environmental test. And we think we will be able to offer some R&D testing on the branch line with Network Rail's approval. Obviously, that won't be to the extent that we propose for the loops, but we will be able to do some of that, and we will certainly be able to do some training long before then. And we plan to be open, and it really depends on the availability of money, whether it's 26 or 27, really depends on how fast the money is available to us. And elements to follow, like the hotel, plan for a hotel on the site, and a technology park, etc. The hotel we won't need to pay for. The hotel companies will pay for that. The problem is that they're saying, well, we don't want to build it until we're sure you're building your bit, because we don't want a white elephant. But we're saying, well, we need you to build that, because it wouldn't half help us, because hotel accommodation in the area is not good. But the Brecon Beacons is right next door. That's great for summer, but you don't get too many people taking a hotel on the Brecon Beacons in the winter. So it's sort of a very seasonal process for hotels, but there's a bit of a large demand. So if we offer a 24/7 load for the year, then basically they've got summer as a bonus. So actually they're kind of keen on that. It's just a question of the chicken and egg. Said the construction is kind of big. We've still got to move rather a lot of material, and we're very much down the road of trying to use serviceable material where we can. But actually, new material, and we've had 50 companies have sort of been donating stuff to us. And some of that is not, you know, it's in 7 figures. Some of what's being donated, so it's kind of good. And we are looking for commercial partners, whether it's partners for doing the certification processes, because we don't think we'll be doing that, certainly not on day one. We will need to partner with experts in that area for all sorts of certification and testing processes. We've got something like 150 companies, well, 153 last on Monday, of companies that have expressed an interest in coming to site, like Hitachi and various others. But of course, they are concerned about contracting when it ain't built yet, quite rightly. Why would you? But on the other side, you know, the investors want us contracting. It's sort of catch-22. It's difficult. But actually, it's coming together. It is coming together. It's a sort of we're trying to break quite a few molds in this process, and well, they are coming together. So I'm coming to the end. There's just a little bit I want to talk about energy, but there is a lot of other things. The automotive sector have talked to us. Highways Agency got a sort of testing facility at somewhere up in the Cotswolds, haven't they? It's actually an old bit of airfield. It's a mile of runway or something like that, but it's dead straight and it's not actually a motorway. And they said, well, can you fit an 8-line motorway? What we really need is a mile of 8-lane motorway with 2 ramps at either end, often ramps, and then an A road to connect it all together. And we said, well, drop it in the middle of the site. Would you like it straight or curved, sir? and they're, well, that's interesting. We think curve would be much better because that's much more representative of a smart motorway, because a lot of the technology they caught a cropper on too. The smart motorway technology, like stranded vehicle radar systems, everything else, actually don't work or haven't worked the way they thought they were going to work. It's part of the problem that smart motorways have run into. And so there's a lot of technology there that hasn't actually got to proper implementation, despite promises and all sorts of things. So actually, it could be quite a useful thing. And when you look at it, put somebody like that on site, as well as Network Rail and you know, other large companies, it doesn't change the cost of the site to operate it. What it does is diffuse your costs, and you know, everybody shares the operation costs. It's a much better logical thing. Digital, whole question of fibres, the whole question of drone testing, out of sight drone testing, you know, it goes on, connected mobility, autonomous cars and level crossings, kind of an entertaining subject. Do autonomous cars see level crossings? Good question. The answer is not very well. But energy, I'll just finish on this. So we want to be net zero. This site will take something like 20 to 30 megawatts of power to operate it when you're running high-speed trains, perhaps 2 trains running high-speed, you know, fairly heavy-duty operations, plus all your maintenance sidings and everything else. We've got an SFC that is to provide the loads, but we actually plan to join onto a renewable wind farm next door to us. It's literally next door. So we can have a private wire legally into their site. Don't need to go on the grid for that. We can go on the grid because the grid is 400 kV and 132 kV literally above the site. But 400 kV is kind of unobtainable. It's kind of difficult to get a connection onto. The 132 is overloaded. And like all these things, the grid is no longer fit for purpose. So there's planning applications in for another, I think, nearly 100 megawatts of power application around because of the wind in the areas. We could put 70 megawatts on our site, but the grid can't take it. It's overloaded. There's been some interesting discussion about that just recently because it is literally overloaded and the grid is actually looking for a connection point. So we could potentially put a 400 kV dropout and connect it to the 132, which would bolster the 132. So there's sort of local strategic issues in the area that we could support as well. And actually relatively quick planning permission, because the grid will anticipate 7 years to get planning permission for a large grid GSP connection. So that could be beneficial. Ideally, we would have a storage device on site. Ideally, we need about 5 megawatt-hour storage on our site, fast reacting, have to have some super caps as well as batteries on it. That would enable us to really react to train going from motoring to braking quite quickly. It's a kind of big swing, isn't it? 5 megawatts to 8 megawatts and 200 kph. Sort of electrically, even the grid doesn't like it, really. On the 132, they don't like it. That's why they like us connecting on 400 on the railway, but it's not easy to achieve. So actually, SFCs are good things because it gives you flexibility of adapting your, to the local demands, which is all good. But the reality is the railway is a unique thing. See, the grid can move power around and out, and the railway is the only other thing can do it. We can actually move to limited quantities. We can move power around our railway. We do in the southeast, have done for donkey's years with the 33 kV system. We put that in because there wasn't enough power in some of the places. East Grinstead wasn't electrified until 15 years ago because there was no power in East Grinstead. And in fact, the only way to do it was to put 33 kV cable in. I live in East Grinstead, or near East Grinstead. There's only 3 electric car vehicle chargers because there's no power in the grid. But if you think about it, we can move power. And how much regen do we get? Well, we don't get as much as we can because the line isn't receptive. Certainly on the DC, it's not receptive. On the AC, it's only receptive if you can go back into the grid. HS1 can't go back into the grid. West Coast can, but actually a limited amount of the railway can actually recharge into the grid. If you had your own storage device, actually you can recharge all the time. You can regen all the time. So we've actually got some opportunities that we're not yet doing. Now, the reality is our plan is to put a small battery on the site, to put the SFC on, actually resolve some of those stability issues, because there will be stability issues with it, resolve some of those issues, and actually it's a model for the main line. It's a model for how to do it on the main line. We could be a lot greener than we already are. We can definitely move the, we see us where we're green, we're really good on the railways, aren't we? But of course, they're all trying to catch up. Your automotive is working hard on it, the aerospace is working hard. Well, we'll get the ball and kick it into the next bloody field. That's what we should do by moving further forward. And actually, the technology is there. We just haven't put it in the right. It's just a bunch of Lego bricks, just going to put them together, and we haven't done it. So we're going to try and do it. Because of the amount of surplus power on the site, we'll probably do hydrogen, electrolysing for hydrogen, biomethane, maybe other things on there, batteries, and of course all the infrastructure parts of this. So, hydrogen, great, but if you're going to charge a vehicle every day, as we probably will have to do with the train because we can't put a big enough tank on it, we're going to have all sorts of issues of fossilizing. How are you going to charge it without actually getting into your... The great thing about composites is fine, but they don't like being, plugs being put in the holes once a day. He's going to break out. They're not good at that. They're long-term stability issues if you start messing around with it each day. But long-term, they're good if you don't mess with them. So our site plan is to put sort of hydrogen down here somewhere because you sort of have to put it away from everything else. They don't like it too close to houses. Batteries, wind, solar, all sorts of bits and pieces. Because the site's quite large, we can spread it out. So we've been doing a lot of work to try and achieve that, because the aim is to try and be net zero, to maximise the amount of recycled equipment. We're trying not to import material on site. We're trying to use the one careful owner coal mines material. Not necessarily very well maintain some of that, but we're trying to use that and build the railway on top of what will be a site that's going to need some tamping. he's going to have some subsidence on it. You know, we are running from areas where we're literally running on, 50th mil of sort of ballast on top of rock to an area that's on 30, 40 meters of fill. So stability, alignment are going to be just like the main line, like the Brighton line today, which apparently has slipped again down there, Harry's Heath. A bit frustrating. The idea is to try and rewild some of it, to put more trees on it. Seems to be a lack of trees on it at the moment. I'm told Brecken's had lots and lots of trees on years ago, but they don't have it today. And Scotland as well. So, sort of opportunity for that. So anyway, this is a summary. I'm sure you're bored of listening to it all now, but that's a summary of everything that I've just told you. I'm sure you will have many questions. There's a whole list of contacts. I will send this through to you as a PDF and you can circulate it to everybody. It's not secret. Any of this, it's all public knowledge. We are trying very hard to achieve. So there's lots of contacts there. If you've got any particular questions, you can obviously talk to all these people, including me. So that's it. So I hope you've enjoyed it.
We're happy to take some questions. Then
Yeah, that's fine.
Yeah, will be. If you'd like to
You've got
introduce yourself with your question, then please do.
Okay, Andy, hi. I was wondering, you said the infrastructure in a rail will have an automatic train on it. Have you got an automatic system in mind?
Yes. You're not going to like it. I'll buy a Tesla and take the controller out of that.
Really?
Well, I don't need a SIL 4 Tesla. I don't need a SIL 4 controller. I just need a SIL 0 controller because I've not got any humans here. Worst case, I turn the power off and it just carries on running and running until it runs out of steam or electricity, or but it stops.
But that's a good way of using fairly known technology.
But it's just I'm using that for effect. In reality, there's actually a couple of companies saying, well, we've got controllers that are not yet authorised. We'd like to give you one. Put that on the train. And it's got the usual issues. What are the detection systems? Are they LiDARs, radars, Dopplers? What have you got on that train? And a lot of the issues that they have are about weather. We can offer them the most evil weather going. If it works up there, it's going to work anywhere. The safety briefing we give to people is, and the PPE recommendation is actually immersion suit to suntan cream, and usually on the same day. It really does change quite quickly. but actually, that's the whole point, isn't it? For that, we could test real systems. I'm not saying we shouldn't, but we can test anything from nothing to full-scale systems. So have you got any ideas?
Let's call it Fact 2.
Yes. You and I know of a system that was developed some years ago that could do that. In fact, I know of another system that there was a certain cardboard computer that we actually had a controller on. We wrote it on a Z80 and 48k of RAM, and we ran a whole train on it. Yeah. London Underground didn't understand what we were doing at the time. Oh, these computer things, you can't do anything like that. We were. They just didn't understand what we could do. So yeah.
Bringing back memories.
Oh yes. Tell Jeremy.
Just a supporting comment, I can't resist. When you said a Tesla system, be next to Varel, I'm sure Bentley Adrian Shooter would absolutely love that. That was his approach. Yeah.
No, absolutely. I mean, I agree
Don't
with
leave
him.
in the wheel.
Yeah.
Yeah.
Yeah. And I'm not trying to, because that sort of thing is not. It doesn't define the career, the process of the railway. What it defines and the testing, what it defines is an opportunity to do things, to test other things. Sure, you do some science and say, actually, I really want to test an automatic controller, then you set a different set of rules. But you have to throw away your preconceived railway rules and say, here's an opportunity to do something completely different.
Yeah. Basis of innovation is be open-minded.
Yeah, absolutely open-minded. So Actually, we're looking for open-minded engineers to come and play with this. It's a giant sand pit. Huge bit of fun. You can only play with it after I've retired, though, which won't be long, by the way. But no, in all seriousness, it is exciting. It's an opportunity to think differently and do that. That's what gets me out of bed with this thing. Is that opportunity to do different. Yeah.
Question again about the infrastructure testing loop, and you mentioned about the two tracks on that northern side. If you're swapping bits of infrastructure in and out there, are you expecting to move that new existing kit from somewhere else into there by road rail vehicles going all the way around, or are you putting a dedicated road in there and allowing heavy machinery on that?
We do have an access road all the way around it, which is there for various bits of access. Would I use this is a kind of interesting thing as a railway engineer. The railway's so good at moving that stuff. That's what we're good at, isn't it? Moving heavy stuff around. So you kind of say, well, let's use the railway first, but we actually have a roadway around it. I mean, we've got to put something like 30 kilometres of rail in as well. And actually some of it's got to be new. How do you get, let's say, 10 kilometres of brand new rail onto a site like this in long strings? I don't want it coming in 30-metre sections, thank you, from the road. I really need to turn on a long welded rail train. And then how do I get them up to the top of the hill? I'm not sure that I get them up at the top of the hill. So there are various devices we can use to pull it round, or do we put in 30-foot sections, join them all up with plates, and then run the railway up and then drop the rail off, and then, you know, there's sort of many ways you can do it.
The practicality is getting like a big Kirov crane in there. You know, is that possible?
Yeah. No, we anticipate we'd need a Kirov. We're sort of designing it to say minimum access is something like a Kirov, so you can lift. But the reality is the roads are also got to be big. You just have to think big for doing some of that stuff. If we put a GSP in for the grid supply point of 400 kV, have you seen the picture of how big the transformer is for one of them? Bloody massive. You probably make some. The vehicle that brings those in by road is one of those things where you close the road and you put this thing in, and it's got 30 wheels either end, 2 tractor units that end, 5 tractor units that way if it's going uphill.
It's not far from the port. So.
Yeah, but it's seriously heavy. You know, getting that up this thing will be a challenge. But there's wind farms up there. There's 50-metre wind blades up there. So if you can get one of those out, you've got to think about its weight and length are the 2 challenges.
And just a follow up on some of those infrastructure bits, you know, some of those that you can sort of take from the existing railways and put in.
Yeah.
Some of them are long term. So things like slab track, is that included?
We've made provision for it. There are a number of versions of slab track available. One, of course, is a new design for HS2. As yet, HS2, they haven't yet signed on the dotted line, I'll put it that way, to put in a section of their slab track. But you'd think you'd go and do that, wouldn't you? You think you'd go and put a whole load of load on it some years before you actually run the main line with it. Because it's going to be embarrassing after 5 years of operating HS2 if something starts failing on it. You kind of want to know that, wouldn't you? You know, it's what you do. I mean, that's what the Japanese would do for certain. It's what the Chinese would do. It's what the Germans would do. But no, we don't have to do that. We tend to, oh, it'd be all right in the night, and then it's not. Embarrassing, isn't it? But there are many forms of slab track, and as we know from the underground, actually, it can be a very aggressive environment, and the underground managed to break the biggest pandroll clips going, don't they? You know, much bigger than the main line. You put bigger ones, the heaviest duty ones in on the Jubilee line, you still break them. The noise is horrendous. because there's no insulation, there's no elasticity or anything else. So you'd expect failure, wouldn't you? Germans had lots of failures with slab track. Not the slab that breaks, it's the fixings and fastenings. The bit that holds the rail to the concrete that usually breaks out. Anyway, I'm talking down on that subject. Any more?
I've got one. Sorry, Robert Fifth, Network Rail. Will there be capacity to test the means of delivery of infrastructure as well?
Yeah.
So
Yeah.
we're moving to
Yellow
production
line.
renewals and all sorts of
How
stuff.
do you do? How do you work up some of those automated renewals? That I think is a very obvious thing to do. Is to say, okay, we plan to automate in this way. Why don't we come and automate a bit of, and let's try it and let's see whether it fails first. Yeah. And if it works, it's great, isn't it? You know, you're confident. It just raises confidence, doesn't it?
Okay, thank you. I think we're going to wrap it up because I think
my dear, I've lost. I can enjoy myself too much.
So I think that's been absolutely fascinating insight into that, and I found it very interesting from a rolling stock perspective, but also the concept of all the infrastructure testing as well. Fantastic opportunity. I'm sure when it gets built, it's going to be an absolute full order book right from day one. So we will look forward to seeing that in option.
You'll all be welcome to come. You know.
Yeah. Great, and thanks once again for joining us. If anyone would like to join us for a drink in the pub, I can't remember the name of the pub.
Fogan House,
Fogan
just down
House,
the road.
and the first round is on us. Thank you very much. Have a good evening.
The Rear Innovation Conference is in March.